everybody. Thanks for coming today. So we are going to do some stats. One of the topics in stats, well, there's a bunch of different stuff in stats we can do. Stats is a really big topic on the GMAT. As I'm sure you guys know now, you can see it in data insights as well as just regular quant. So, all of those things, table analysis, two-part analysis, graphics interpretation, even parts of MSR. So yeah, you just want to be in a place where you know stats through and through. There's just a lot of different stuff to it. So today we'll cover stuff with like sums and averages and things like that, and just get a taste of some of the stuff that you can see. Our chapter of stats in TTP is quite large, so if you're in it, spend some time with it. As I said, there's a lot of different things that will carry over to the exam from stats. But let me just get my stats doc open here, and then we can kind of go from there. Give me 1 second. Let's see here. Statistics. Okay. All right, so the first thing I want to do is deal with partial sums in the average formula. It's something that they can test you in a variety of ways. Remember, of course, average is equal to sum over quantity. So they can give you part of the sum, they can give you the average, the rest of the quantity, and then you've got to figure out, what's going on with that partial sum. So you'll see what I mean in just 1 second when I give you this first question. And then we'll do a couple of those and then move on to another topic here. So let's start with this question here. All right, take a look at this one here. Give you guys a couple minutes, put your answer in the chat box. All right, so I see a lot of correct answers here, pretty much all correct answers. So that's good. So obviously this concept isn't hurting anyone too much. So yeah, what you do here is we see first and foremost, the team produced an average of 10 cars per day for the last 10 days. That's a total of 100 cars. And then we want to know for how many days would they have to average 20 per day. So the quantity, the extra quantity is unknown, so you can call that 20x over the original number of days plus the new quantity is going to equal to 12 cars per day. Obviously, you guys did this out and got B, so we don't have to work through the math, but that's all you're really doing here. You're just using an unknown for the unknown number of days. It affects the sum, it affects the quantity, and then there you go. So yes, very good work, everybody. I think we can maybe even move on to something else here. We can do a couple min-max questions. So here's something interesting. Take a look at this question here. Give you guys a few minutes, then we'll chat about it. All right, so let's see what you guys have here. A lot of C's. Now, with max min questions, I mean, they're all over the test. You can see them in sets. You can see them in statistics. You can see them in percent. So there's the key in this question is that they're 9 distinct positive integers. Now, if they weren't distinct, you could make them the same. So all you really do in a question like this is you get the sum, which is 90, because you're talking about 10 times 9, which is 90. And we want to max out one of the numbers. So to do that, we minimize all of the other numbers in the set. And so you just have to cycle through the smallest possible numbers and work your way up. Now, I don't know if that's what you guys did to solve this. We're told the integers are positive. So we're literally just saying 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and then plus 8, and then plus the max. And then you're subtracting that from 90. So 1 plus 2 plus 3, that's 3, 6, 10, 15, 21, 28, and then 36. So it's 36 plus the max is equal to 90. So 54 is equal to the max number here. Does that make sense to everybody? right, cool. So let's try another one. This is more of like a weighted average, but same concept. Let's take a look at this here. All right, so let's work through this now. So did you guys find this harder or easier than the other one that we did? Yeah, it's harder because there's a little bit more going on, right? Basically. Um, but it's still quite doable because the goal obviously is how you try to minimize things, right? Or excuse me, try to maximize things by minimizing everything else. So this is set up kind of like a weighted average of sorts. And that's kind of how we're gonna deal with this question here. So the way to go about this guy is we're gonna be in a place where we just kind of set it up based on the information that we see here. It's nothing crazy. We just got to kind of fill this in and then fill in our gaps here. So there's 40 children. The average was 6. So the grand total of the sum is 240. 240 is 4 children, 1 3 goldfish. So 4 times 3, 8, 1, 4 children, 1 3, 6, 1 8. So that's 6 times 8. 5 1 2, and 410. And then there's n, that's the remaining sum, right? Remember, we're basing this all on sums here. So we have 240 is equal to 12 plus 48 plus 10 plus 4 plus n. And then we can add these together. That's 60, that's 70, that's 84. Let me make sure I didn't, oh no, excuse me, that's not a zero. That should be a zero, yeah. So that's going to be 6, that's 70. So we have 240 is equal to 70 plus n. We can subtract the 70 from the 240. That's going to give us 170 here. So question is, what are we doing with the remaining n, right? Well, let's count how many people this is accounted for. It's accounted for 4 people, plus 6 people, plus 5 people, plus 4 people. So that's 4 plus 6 is 10, plus 5 is another 15, and then another 19. So we have 19 people accounted for, but there's 40 children at the fair. So what does that mean exactly? Well, it means we're going to take the other 20 children, and we're going to have to minimize them. Now, we're told that each child won at least 4 goldfish. So that's 20 times 4, which is 80, right? We're going to subtract 80 from the 170. That's going to give us 90, which means that's what's left for the final child, and that's answer B. So you have to look at this, almost from a quantity perspective where you're minimizing everything else, but just with one possible quantity left, if that makes sense. So the answer here is B. So it looks like everybody was pretty good with that. So that's good news. We're going to do a couple more here. Take a look at this one. This one's going to give us a median value as well. All right, so take a look at this one here. Yeah, you have to leave one left. Exactly, there has to be one at least left over to solve this out. Okay, so we've got 5 unique positive integers. The median is 8. So what is the greatest possible value in the set? We know that the average is 10 and there's 5. So we've got 50. What we do is we stick our median right in the middle of the set, right? So that's 8. And they're unique. So they're all positive. So 1, 2, 8 plus 9 plus the max. Now, if they weren't unique, the way we would have done this, just so you guys know, is it would have been 1, 1, 8, 8 max, because the median is dictating what's happening in the middle of this set. So because we do it this way, we subtract over, the max obviously becomes 30. So you got to really keep a look at, you know, whether they're saying that things are unique or not unique when dealing with these things. So anyway, nothing crazy here. One last thing, we got like about 10 minutes. I want to do some things with evenly spaced sets. Give me a second here. Let's see here. I've talked about this here. All right, try this here. All right, so some of the odd integers from 5 to 55. So remember, sum, of course, is equal to average times quantity, right? Now, when we have an evenly spaced set, the key is that the bookends of the set are the values that you're talking about. So in this case, 5 and 55 are both odd. That's important. So the average in a evenly spaced set like this, 555 minus 5 divided by 2, or excuse me, plus 5 rather. So that's going to give us 60 over 2. That's 30 for the average. The quantity is 555 minus 5 over 2 plus 1. Doesn't matter if they're odd numbers. It's about the space between the set. The fact that, again, they're evenly spaced. Okay, that's super, super important. So keep that in mind as we, you're doing these things. Some people ask, well, if it's odd, why are we doing X, Y, or Z? Well, it's not about the fact that it's odd. It's that it's evenly spaced by 2. If it was evenly spaced by 3, you divide by 3. so on and so forth. So 555 minus 5 gives us, 55 minus 5 gives us 50. Divide that by 2 plus 1, we're talking about 26. So sum is equal to 30 by 26. And as most of you guys got here, I think almost everyone, you got answer D here. Evenly spaced sets, there's a lot of different things they can do with them. But you know, none of it, I think, is all that bad. You just have to have a systematic approach to dealing with it. From time to time, they'll give you a really weird formula in evenly spaced sets. I don't know what it is. I think they're attempting to get you to use it. But it's one of those odd things where I prefer to always use this formula. It's like n times n plus 1 divided by 2 or something. It's something they give to you at the beginning of the problem, and yes, it's super bizarre. In any case, this is a very simple, clean formula to use, so I would always suggest using it. I don't use anything else in these cases. The last thing we'll do is multiples of either or. So we'll finish up on this question, and then we can do some Q&A here. Take a look at this guy here. All right, I see some answers trickling in here. So the key with a question like this is we're dealing with overlap. So when they say multiples of 3 or 4, what you're going to notice is that there are multiples that are going to be double counted here, and you need to account for those multiples. And that's going to be the LCM of 3 and 4, or 4 and 3, whatever you want to call it, 12. So the first thing is you figure out, well, how many multiples of 3 are there? Well, that's going to be, you got to find the biggest multiple of 3 in your set. That's obviously 90. So 90 minus 3 over 3 plus 1, 87 over 3 plus 1. So we have 87 divided by 3 plus 1, that's 30. So there's 30 multiples of 3 in our set. And then we're going to do the same thing with multiples of 4. 88 is the biggest multiple of 4. 88 minus 4 divided by 4 plus 1. 84 divided by 4, 21, plus 1 is 22. Now, the trap answer here is 52. Notice it's staring us in the face here. It's not. You got to account for the multiples of 12. You can do it any way you want. I mean, you could write them out. You could do 12 times whatever number to see what the final one is. Obviously, 45 is the answer. I see all you guys have that. But you have to get rid of them. So whether you're writing them down, 24, 36, because it's inclusive of, why did we not do 90? Well, you can, I always do my quantities the same way. So I do it largest minus smallest divided by the evenly spaced plus 1. That's always what I do. You can do it that way, but I think there's times where you're going to miscount. So I'm very systematic in my approach. So then 60, 72, 84, and yeah, that's it. So 1, 2, 3, 4, 5, 6, 7. There you go. 30 plus 22 minus 7, 45 is your answer. So the only other way you can see this question, or you can probably see it other ways, but they could also say, how many are multiples of 3 or 4, but not both? In that case, you would actually have to subtract 7 twice, because remember, we are counting the overlap. We're just subtracting out the overlap, but we're still counting the multiples of 12, because those are technically multiples of 3 and 4. We just can't double count them. All right, we can stop here. Does anyone have any kind of general questions? Anything at all worth discussing here? We do have a recording. I think they go on our YouTube channel, as far as I know. Well, you can also go to our course to see the goldfish question. These are all questions from TTP. Yes, you are muted, so you can type in the chat box. I'm not sure your question. I don't know what you mean by read this as R multiple of 12. Any other questions? These questions, I think, are mid to high level. I would recommend using Target Test Prep to study this topic. We have an awesome lesson on this. Still don't understand your question. I would just solve it the way that I just did and not overcomplicate it. All right, cool. Yeah, you should get your quant score up. If you're looking for a high score, I mean, every section is counted evenly, so 100%. Get your quant score up. Make notes, make flashcards, and review them. I mean, it's honestly like anything that you guys learn in life. I try to tell people this a lot. The GMAT isn't this like big mystery. It's just a test. So think back to any time you had to learn stuff, whether you're in college and you had 3 to 4 classes where you had to keep everything in order. How did you learn then? I will say saying that you forget things just to me is an excuse for not doing well in the exam. Like when I studied for the GMAT back in the day, I was a machine. I had flashcards. I looked at them daily. And if I forgot something, I made sure to look over those notes or flashcards. So yeah, just try to incorporate the things you've always done in your learning. And if you can do that with the GMAT, you'll be fine. Any other questions? Yep, my pleasure. We'll be here back, I think, next Thursday. Not sure what we're working on, but it'll be a new topic. If anyone needs anything, feel to reach out. We're around. Thanks for coming, everyone. Thanks for participating, and we will talk soon.